Angles in triangles. So some of this is going to be a little bit of a review on our triangles, but we want to make sure that we know the basic rules as we start to talking about angles and triangles and sides for triangles. So the first thing at the top of our page here is the triangle sum theorem, which just says the sum of the measures of angles in a triangle is 180 degrees. So all the angles in a triangle have to add up to be 180 degrees. So for our first example here, if we are going to figure out what A is, you would just simply do 180 minus 35 minus 65, and that would give us 80 degrees. So A would be 80 degrees. So for B, very similar, you would just take 180 in your calculator, subtract 40, subtract 80, and that would give us 60 degrees. Now C is a little bit different. We have a little more work to do in it. So the first thing that we're going to do is we're going to start off with this triangle right here. We're going to find X. So the first thing we would do is we would subtract from 180. We'd do 180 minus the 65 minus the 39. And that would give us, for X, that would give us 76 degrees. So X would be 76 degrees, okay? So remember, a straight line, a linear pair, which we just learned about, this is a straight line right here. So not only does a triangle give us 180 degrees, a straight line is also 180 degrees. So we have to use that fact as well. So 180 minus 76 is going to give us 104 degrees. So angle Y is going to be 104 degrees. So we had to do that. So now, if we find the blue triangle right here, we've got two angles, and now we can do 180 minus 21 minus 104, and that's going to give us 55 degrees for angle Z. So that gives us those angles for that triangle. So now, let's talk about types of triangles. So we can categorize triangles by either their sides or their angles. So the first way by sides is we can do equilateral, and that means that all three sides are equal. And a lot of the times what you'll see like little markings through the sides, so like 2 marks, 2 marks, 2 marks. So however marks you see, it just means those sides are equal, so equilateral. We also have isosceles, which means 2 sides are equal. And we have scalene, which would be no sides are equal. We can also categorize triangles by angle. So an acute triangle means all 3 angles are less than 90 degrees. We have a right triangle, which means one angle is 90 degrees. And an obtuse triangle is one angle is greater than 90 degrees, and only one angle is greater than 90 degrees because it's not possible for more than one angle to be 90 degrees. So the triangle exterior angle theorem just says that the measure of each exterior angle, so here's our exterior angle, equals the sum of the measures of its 2 remote interior angles. So these would be those angles right there. So angle 1 plus angle 2 equals the measure of angle 3. It's just a quicker way of doing it. Okay, so let's apply this theorem. So find the missing angles. So applying that theorem, you would just add 60 plus 40 would give us A. So 60 plus 40 is 100 degrees. Okay, for B, you would add 35 plus 60, which would be 95 degrees, which is our B. Now, for C, we're given the exterior angle. So in this case, we would subtract. You could do 113 minus 70 to give us C, which is 43 degrees. And that's just a quick way of finding these angles if you're given that exterior angle or if you want to find that exterior angle. Now, using isosceles triangles, So isosceles triangles, these triangles have two sides that are congruent, as well as two angles that are congruent. So if you have two sides that are congruent, that also means these angles are congruent, okay? So automatically, if you are given the sides, the angles opposite those sides, you automatically know that those angles are congruent. And vice versa. If we're given these angles over here in the second picture, you can go and mark these sides are congruent. They go hand in hand. They go together. So the bisector of the vertex, so over here in this third picture, of an isosceles triangle is the perpendicular bisector of the base. So if it bisects it, meaning that it's cutting this angle in half, meaning this angle and this angle are congruent, if it cuts that angle in half, then we know that it's going to be perpendicular. And remember this upside down T right here, that's the symbol. It means perpendicular. Okay, so let's find missing angles. So if we know, let's start, we'll just start like with this triangle right here. Okay, so remember, I'm just going to go over, so these little lines here means that we have an isosceles triangle. If we have a 50-degree angle here, that means this side over here is 50 degrees. So 50 plus 50 is 100. The entire triangle has to be 180. So 100 plus what equals 80? Well, that means that x has to be 80 degrees. So we know x is 80. Now over here on our other triangle, so they're just back to back. So that means this is isosceles. Well, if this is y, that means that this angle over here is also going to be the same. Okay? Well, if we got 100 degrees, if we do 180 minus 100, that leaves us with 80 degrees. Well, that means that this angle and our y have to be 80 degrees total. Well, if they are going to be the same, we just split 80 in half. We would just divide 80 by 2, which means they are both going to be 40 because they're both the same angle. So y would be 40 degrees because 40 plus 100 would give us 180. Okay, so on B, we know that these markings mean that these are the same. Therefore, we have an isosceles triangle. These are the same. Now, here is a straight line. So if this is 110, we know that on that line it's 180 degrees, which means this angle would have to be 70 degrees. Now, it's not asking for that angle, but we know it's an isosceles triangle. Therefore, y is going to be 70 degrees. That helps us figure out y. And now inside our triangle, we know 70 plus 70 is 140. And we're going to use that to help us find x. So what plus 140 equals 180? Well, we need another 40 degrees for that triangle to total 180 degrees. Okay, so moving on to C. So on this, so we can see that our big triangle, if we look at our big triangle right here, we see that it's an isosceles triangle. So if this is 52 degrees, we know that this is 52 degrees. We see that we have this line here going down the middle. It has bisected this angle. And remember, we just learned about an angle bisector. So that means it has cut this side in half. So that means if this is 4, y has to be 4. And remember, it also told us that it would form a 90-degree angle. That was a fact that we learned, that that is a 90-degree angle. So if this is 90 degrees, and so now I'm going to kind of look at this as a small triangle, 52 plus 90. So I could do 180 minus 52 minus 90, and that's going to give me 38 degrees for x. Okay, moving on. Okay, so now I'm going to get into some problems with x in it. So these are marked as being congruent. Those little markings mean that they are the same. So I would just simply take 4x plus 12 and set it equal to 5x minus 3. And I'm going to solve for x. So if I subtract 4x, I'm going to get x over here, and I'm going to add 3, and I'm going to get 15. So there is my x. And just pay attention on your problems if it just wants you to find x, and it may want you to plug back in and actually find the angle. If it did want us to plug back in and find the angle, then I would just do 4 times 15 plus 12. So 4 times 15 plus 12 is going to give me 72. So that angle would be 72 degrees if it asked for it. Okay. On E, so since these sides are marked as being the same, I know that this angle and this angle would be the same. So I can take 6x minus 1 and set it equal to 77. And now I'm going to solve for x. So I would add 1 and get 6x equals 78. And 78 divided by 6 is going to be 13. And then our last problem. Okay, so this one we got to do a little more work. We have that these are marked as being congruent, which means that this angle and this angle, so you got to be careful. This is a little bit tricky because the sides opposite from the angles are what's congruent. So if you let go across, those are the sides that are, or the angles and the sides that are congruent to each other. Okay, so this angle is 65 degrees here. So we need to figure out how many degrees this angle is. So I would do 180 minus 65 minus 65. So this angle up here is 50 degrees. So I would do 50 equals 3y plus 2. And now I'm going to solve for y. I would subtract 2 and get 48 equals 3y. And then I would divide by 3. And 48 divided by 3 is going to be 16.